Hello and welcome back to the lab. Today on the bench we have a Tektronix vintage Type 107 square wave generator. So this is one of those odd units that does one thing and does one thing very, very well. This isn't the fastest one in the lineup. I believe there was a 109. The 109 is quicker than this unit, but the 109 has some aging problems that this unit actually doesn't have. So this is, we'll zoom in right here. This is very old speak. We have 3 milli-microsecond rise time, aka 3 nanoseconds. Serial number on this unit, kind of hard to see, 909. And ours looks like it came from the RCA company. Aging this particular unit is 1958. And at that time, in the TechScope world, we had some... the 500 series was out for sure. There was no 400 or 7000 series yet. And pretty much the fastest scope in the available outside of sampling was about 100 megahertz. We got 100 megahertz out of the 585. This was used, one of the things this was used for was bandwidth adjustments and front-end alignments on sub 100 megahertz and below scopes. With a 3 nanosecond rise time, we have a real-time bandwidth on this particular unit of 116 point something megahertz. So this would have been acceptable to do the rise time of a vertical section, things like that. Nowadays, we need to use something much, much quicker for fast edges in the lab for doing scope bandwidths, especially up to the gigahertz. Tunnel diode pulsers. We have the 284 pulse generator. The tunnel diode pulsar was done up to 1 gigahertz, and the 284 gives me down to 70 picoseconds, which is an incredibly fast rise time. Also, given the speed of the rise time and the fact that this is of the tube era, we're output limited to 100 to 500 millivolts. That's about it. So, doesn't put out a lot of output drive. However, we have some very, very fast edges for the time, and we have very, very fast edges done on tubes. The two primary differences between the 107 and the 109, the 109 uses a mercury wetted relay to get the 250 picosecond rise time, and that ages very, very, very rapidly. The 109 was only good for, I want to say like 100 hours of operation before the relay needed to be replaced. At least that's what it was specified for. So this one being the fact that it is tube drive and does not have the mercury relay, we don't have the hour limitation on it. So not as fast, but definitely a much more, has a lot more staying power than a 109. If you left the 109 on over the weekend, say, the mercury, go home on a Friday night, accidentally leave it on in the lab, Monday morning the relay's about dead. 80% of its life was burned up over the 48 hours over the weekend. Don't have those limitations here. This one has taken a hit a little bit, so we're going to have to do a little bit of chassis work on this one, get this one all patched up, but nothing we can't handle. And let's take a look. I'm also going to see if we can change this output connector from a PL style to a USB. We'll look in, or not USB, BNC. We will take a look at the feasibility of that. See what we're working with. Hopefully that didn't, wow, that's stuck. Okay, that's going to take some persuasion. Nope, that's just going to pop off. Excellent. Okay. Well, I've already got caps we need to replace. So, for sure, we have a couple capacitors that are absolutely going to need to be changed. Ceramic strip construction, so we're going to have to work with the silver bearing solder for the ceramic strips. Bump up the exposure on the camera a little bit. There we go. So we have ceramic strip construction. Going to have to use the silver bearing solder to get that squared away. And these two caps need to get replaced absolutely. They are out. Output wise, I might be able to get a B and C on there. We'll have to look. I might be able to use the same trick that I used with the 106 possibly. Definitely get that straightened out though. Yeah, that racked pretty good when it fell. Got knocked in transit, I think. Wow, there's not much left on these flathead screws. Holy cow. Okay, what do we got on the tube side? Now that looks good. So our tubes look okay. Nothing looks overly burnt. I need to take a good look at the getters. Probably wipe these tubes off. We'll see about these caps. Well, that's a tube, so that's not a cap. Some plastic flaked off, looks like. So see if we can find where that came from. Fan needs some oil, but not terrible. These fans are oil based, so right here and right here we actually put some oil in there to oil the bushing of the fan. It doesn't even have a bearing. It actually has a bushing in there. So we definitely do not want these dry. If they're dry or they're gummed up, they'll chew themselves up in very, very short order. It's ultimately what went bad on one of those 500 series scopes that I've had on the channel was those bushings were toast. This one's moving pretty good, so a little bit of oil, and that should come back and be happy. No solder. Sometimes they leave a roll of solder in here to work on this. This is a capacitor that may need to be changed. So not a crazy amount of work in this one. Definitely need to get this chassis untwisted. If we look at the top, you can tell this one's straight. This one comes down at an angle, so we'll definitely need to clean up this face a little bit. So a little bit of work to do, but nothing too catastrophic. We're going to get into this and see if we can't get this thing to make square waves again. We are going to need to fix the power port. There is no plug, so I'm going to need to address that for sure. Get this thing turned on. All right, let's get some oil on these bearings. Bushings, sorry. Ooh, that doesn't feel bad either. That's kind of nice. Gonna do that a few times, let that soak in, and then we'll just spin this around by hand before we give it power and really hammer on the fan so the bearings don't chew themselves up. All right, after a bit of removal of metal to get it to fit, we have a NEC power plug using the existing holes. Little bit showing through, but better than no plug to speak of. On the inside, we have the line side going to the fuse, neutral coming out, and everything is good to go. So we're ready to throw some power on this thing and see if it has signs of life or if all of the work so far has been for naught. So we'll move the PL259 plug up to the output, and we'll hook it up to power and see if it wakes up. All right, I have you guys on the tube side, so we're going to take a look at this. I do have this hooked up to the current limited variac supply, so we're going to take a quick look at bringing the voltage up slowly. This fan's probably going to start to turn slowly before we see anything else. And if the current shoots high, we'll have the bulbs in place to prevent any catastrophic failures. But we'll start giving it some volts. See, we got about 10 volts, no watts. Oh yeah, I bet you it would help if I kick the power on. Yeah, there we go. Now we're drawing. At 20 volts, we're drawing about 3 watts out of the system. No fan quite yet, but I'm sure our caps are starting to see voltage again. No, they wouldn't be because it's tube regulated. The caps aren't going to see B+ until at least the regulators fire. And there we go. Whoa, whoa, oh. At about 30 volts, we're starting to get fan spin. And we're only drawing about 5 watts, so everything looks good. Let's give it a bit more. It's about 50 volts. We're probably hitting the tubes a little bit now. Am I seeing glow on anything? Not yet. So I don't have B+ quite yet. Fan's spinning up. We're at 80. 52 watts. Now I should have. Yeah, I'm starting to get glow on the tubes. Okay, so we're starting to get B+ now. The regulator hasn't struck yet, which is fine, but we're drawing about 47 watts. And at 120 volts, the regulator did strike. We'll bump the exposure down and kill some lighting. We're looking for a pale glow out of that regulator tube. I can see it in person. Let me dim the lights in the lab, see if we can't get a good shot of that. All right, so right here on this tube, we're using a pointer to keep the fingers out, but we have this pale kind of purplish glow on the OA2, and so we do have B+. The manual does call that out. So let's hook it up to a scope, see what's going on. All right, let's give it a shot, see if we have any output. Survey says nope. Okay, so now we have to actually do some troubleshooting. First off, we have a trigger output on the back of the unit, so let me move the PL259 connector out to the back, and we'll see what we have. Well, I have trigger out, so the device is trying to work. Everything looks like it might be okay. And at least the main oscillator's running and things like that because we have trigger. So let me print out the schematic. We'll take a look at the schematic and see if there's a decent place to do some checking for signal. Okay, hopefully the 4K video will make this schematic look a little bit easier to read because it's kind of rough. So we have our trigger output here, which we have found out actually has signal. So that means our oscillator is probably working and this 6BQ7A is working. So the next question is, do we have signal at pin 2 of V45? If we do, probably jump over to V65, check its pin 2, and if that has signal, we'll check pin 1 of the 6AU6, and if that has signal, then we'll come over here. Here's the 6AU6, so test point pin 2, test point pin 2, test point pin 1. If this guy has signal, then it's got to be something either broken in the output or this tube is not playing nice because from here we hop right over here to output, signal out. So if I get signal all the way through the chain up to here and we don't have signal here, the only active element is the tube. So I'm going to suspect the tube in the beginning, but let's see what we got. The unit's off right now. I'm going to put the test on this scope. The trigger out's going to be up on that scope. And we're going to take a look through at some of the tubes. So the first tube in question is going to be pin 2 of V45. V45 pin 2 is right here. And we're on the isolation transformer, so we'll give the scope a ground. And then fire it up. Let's get some signal. We'll see what happens as the tubes warm up. It'll come into emission, and we should see, okay. So we have trigger out, and we have signal at V45, which is a good sign. So next stop's going to be V65, pin 2. V65 pin 2 is going to be this capacitor right here. And I have signal on there. So that's a good question, or that's good. V85 pin 1, which is the fresh coupling capacitor we put in. Well, I'm getting, unless my solder job to the tube sucks, we're getting signal all the way up to the output drive tube, but we're not getting signal through the output drive tube. So let's take a look at the output drive tube. Well, here's our output drive tube. It's a 6136. However, this doesn't look so hot, and I have chalkiness on the getter, so pretty sure this tube has lost vacuum. With chalkiness on the getter, it's almost not even worth testing, and especially when we have this envelope damage. It's a 6AU6. I'm not too worried about it. I'm going to hit the lab, and I know I have some 6AU6s in stock. We're going to pop another tube in and see if we didn't just have a simple loss of vacuum. And we have a Sylvania 6AU6, and I'm assuming this registered 94 when it was tested. Usually if I see a 94, it means it was tested on a TV7, because they run in percent, which is a little weird for a tube tester, but real nice tube. Getter's nice and shiny. 6AU6. That tube looks like it's in really, really good shape. So we'll pop that in, see if we get output drive. Okay, controls are mid-range. Everything is good to go. Bump the exposure down a bit. Oh, no. Bring it back up. Let's see what happens. Well, that looks good. Ooh, that PL259 connector is very intermittent. That socket's in rough shape. So definitely that is one crusty connector. I'll zoom in on that here in a little bit. But take a look at that. Nice clean edge. Due to this being a 116 megahertz signal, I'm really pushing the scope to its limits, showing this waveform. But I really, really can't complain about that. Obviously, when we line this up, I have a 300 megahertz or above scope that we can hook this into, give us a nice well over what I need for this unit. Amplitude control is good, and that's a very, very nice high-speed signal, especially for something tube-related. Okay, so now it's time for some burn-in testing. I got to put the covers back on this because I don't want the lab cat licking the B+ supply and giving the high voltage a CAT scan. So I'm going to put the covers back on this. We're going to let it sit for a little while, just let it kind of punch into a scope, verify it, run some burn-in tests, but I think this unit's going to be good to go. I definitely want to get another one of these. That is one crusty connector. So my BNC cable and then the connector that I have. I don't have any more PL259s, so that I'll just have to order some. Okay, covers are on and it's happily buzzing away. So we'll just let it be for now, and I'll come back in a couple hours. Well, we have a very nice wave shape and pulse, and at least we're measuring to 3 nanoseconds, which is the absolute upper end of this particular scope, with this only being 100 megahertz. So let's take a look and see what this waveform really looks like. All right, so here's what we look like in the camera. Pardon the scrolling line a little bit. It's just camera shutter and scope refresh rate are not lining up, or lining up a little strange. Turn off the touch panel. And so we have rise time measurement. We're actually at and this is a full scale rise time actually on the scope, or on the waveform generator. So we're at 2.423 nanoseconds, and we're at 509.6 millivolts. So that's actually within spec, and that waveform looks fairly nice. So we can call this one good to go. Thanks for stopping by the lab and taking a look at the rejuvenation. We didn't really have to do much to this one, but the rejuvenation of this Type 107 square wave generator. Very much not bad for vacuum tubes in terms of fast edges, and with it being introduced in 1958, this was probably one of the fastest boxes around. If you like what you see, hit the subscribe, thumbs up, leave me a comment, and let me know how we're doing. If you'd like some additional content, take a look at the Patreon page. Link is in the description. And see what's out there. Patrons are running a little bit ahead, and their support helps keep the lights on here in the lab and videos coming to YouTube. And I'm eternally grateful. With that, as always, more is on the way. And I will see everybody in the comment section in between videos and in the next video. Bye for now.